Hello and welcome to Slooh.com. My name is Will Gator, and you're watching our special celebration program, not just of the International Space Station, but of all the Year and Space mission, Scott Kelly and Mikhail Kornienko's mission to live on the space station for a year, and all the things that we're going to learn from that in terms of spaceflight and human endurance.
So let's just start, just dumbly, not being an expert. I remember going back years, everyone was talking about bone loss, bone density loss, muscle loss. So is that the extent before this year in space project began? Is that the extent of the effects of space travel on the human body? I mean, what does it have? Tell us, pretend I didn't know anything to begin with, and most of our listeners don't. What effects does space travel have, both mentally and physically?
Well, Bob, I'm delighted to be here to talk to you about this, and it is my favorite subject, so I can go as long as you would like me to. You have identified one of the more important and more interesting problems of space flight, and that is the loss of bone density and more specifically bone structure. The human body is a good one for being as economical and efficient as it can be, and if it sees that it is not expending or it's expending metabolic energy, which is the coin of the realm in the body, metabolic energy. If it sees it's expending that in areas that it doesn't need to be because there's no damage or no stress or no load in that area, it quits doing it very wisely. And what it does then is it restructures or allows the bones to be restructured or destructured according to the loads that they're currently experiencing in spaceflight. And in spaceflight, we're not loading the bones with G loads and jumping and things like that, which is groovy as long as you stay in space. But if you come back to the ground, then suddenly you need that structure again, and you're at a bit of a deficit until the bones can rest. We have on the space station now, we think we have identified a very good way to protect bones and coincidentally to protect the muscles, the skeletal muscles that support the bones, and that is our resistive exercise device. It's called the ARED for the Advanced Resistive Exercise Device because it's the second one that's been on board. The first one was the IRED, which was the initial or the interim resistive exercise device. And what this does is allow weightlifting and weightlessness. It's like a Nautilus machine, so there's no actual dead weights that you're lifting, but it gives astronauts the capability of doing weightlifting exercises in weightlessness. And associated with the presence of that device on the machine in the last 6 or 7 years, we have been tracking less and less loss of bone density.
What's it actually like to be up there orbiting 400 kilometers above the surface of the Earth? Well, just yesterday, I caught up with NASA astronaut Katie Coleman, and I asked her about some of the things, some of the experiences of being in space. So let's have a look at that interview just now.
Putting things together and feeling like I did that. I mean, it's not actually all that exciting to me to take a little box of samples and stick it in a plate that it sticks onto and screw it in so its power and its data are connected and close the drawer and have the ground make some things happen. But actually, in a little box like that, so to speak, there's 100 little wells where we're growing crystals and real science is happening there. And what I really learned was that everything that you could have a machine do, if it's the right thing to do, you should do that. And places where because there are going to be places that you absolutely need to have a human that can reassess and look and see that things are different, a human that can react to the changes that are caused by microgravity. And, so in the beginning, you're going to want to have the human in the loop. But once you get the system straightened out, I mean, if they are amenable to robotics, let machines do those things. And also maintenance. Every minute, I loved actually fixing things and taking things apart and fixing them. I never did that on the ground, and I was 50 years old before I found out that I could fix things. I could learn how to use tools, and I was actually quite good at it. And I loved doing that. And at the same time, if we can build things that don't need maintained to that degree, it's the right thing to do. And it's essential for the journey to Mars. I actually think from an Earth point of view, I think it's magical to watch the space station go over. And I go out all the time, and my family goes with me, and they go even when I'm not there. And we go out, we look at what time it is, and just generally about where it's going to be on the horizon, about how far up, whether it's kind of low or really high. And I tell people it's not like it's going to look like the brightest star, and it's not going to dash across the sky. It's just this slow kind of thing. And that you have to, look in the place it's going to be, and you say, oh, is that it? No, is that it? And then suddenly there's a thing just crossing across the sky, a bright star, and there's a certainty that that is it. And I love to see that, even when I'm here on the ground, because, even though I know there's people in space and I know we have a space station, I know it's real, when I get to see it, it's really meaningful to me.